All right, welcome to the next part. So here we are going to use these equations to determine everything about these graphs. If I were to graph this, what would the amplitude be? Let's write down what we're looking for. Amplitude. What's my period? All right. What is my horizontal phase shift? Let's say HPS, horizontal phase shift. Okay. What is my vertical displacement? How much is the graph moved up and downwards? Okay. And what's the range of these graphs? You notice I didn't ask for the domain because their domain is probably going to just be XER, and they are for all these graphs. Okay, so my amplitude, remember, is just the number in front, so that's 7.2. I can just do that for all of these ones pretty easily. Amplitude is 5, and the amplitude, if you don't see the number, you assume it to be a 1, so it's a 1. Period. Now the period, remember, is the original period, and they don't specify it. They don't, see down here they have little radians here, like a pi, so you assume that's radians. There's no degree symbols anywhere on any of this, so let's assume, unless you see a degree symbol, that this is going to be in radians. So the original period is 2 pi divided by the b value. And the b value for this graph, let me just write down the a values. The b value for this one's 1, so it's going to be 2 pi divided by 1. So my period is just 2 pi. Looking pretty good. My horizontal phase shift is going to be whatever the c value is. In this case, negative 6.25, sorry. It's going to be a c value divided by my b value, which is going to be negative 6.25. So what you could do here, because it's negative, remember what we said about negative numbers, it's actually going right. This is 6.25 right. You could just leave the number there. Like both of these are correct in my mind for this course. Remember my vertical displacement is my d value, and you notice there's nothing really there, so my d value is 0. So my vertical displacement is also 0. They don't mention it here, but let's put in midline. Y is equal to 0. Okay. Now my range, remember our range is the min to the max. So the min is the d value minus my amplitude. So negative 7.2. And then my max is my d value. So remember, this is my midline. It's either going down the amplitude or up the amplitude. So 0 plus the 7.2. So you put a little lighter. There you go. Looking pretty good. So let's try these other ones here. So here we have a weird looking b value. 20.28. So my period is 2 pi divided by this 20.28. I just got to punch out my calculator. It says to the nearest hundredth. So let's just do that to the nearest hundredth. So we get a period 0.100th is 2 decimal places, so 3.1. Okay, my c value is 14.35, so therefore my horizontal phase shift is going to be c divided by b. And we have these two numbers, so 14.35 divided by the 20.28. And I get a c value of 0.71 to the nearest hundredth, because it's 707. Because it's positive, that means it's actually moving left. Okay, my vertical displacement, which is my d value here, is negative 7.5. So it's moved downward 7.5. That's what the midline is. I'm just going to put that over here too. My midline, y is equal to negative 7.5. Okay, my range is my midline. So my midline's down here. So here's my x-axis. So my midline's down here now. And it's going to go 5 up from there and 5 down from there. So if I'm negative 7.5 minus 5 is going to be my midpoint, or my min point, sorry. And my max point is going to be this number, negative 7.5 plus the 5, or negative 2.50. There we go. There you go. Looking pretty good. Okay, so the last one here has a weird pi in there, but that's fine. I'm not too concerned about having that weird pi in there. Maybe I'll just try to leave that as an exact answer. So my b value is 3, my c value is pi, my d value is negative 1. So that means my period is 2 pi divided by 3. Let's leave it that way. 2 pi divided by 3. That seems like a pretty good answer. Nice little exact answer there. My c value, which is a horizontal phase shift, is going to be c divided by b, which is going to be pi divided by 3. I'll just leave it that way. Because it's positive, left. I'm okay with either one of those two. Like if you just leave me the number, that's fine. If you want to put the left in there, there's a little extra bonus for me, just for the fun of it. My d value tells me my midline is negative 1. This is my vertical displacement, so I'm just going to ignore the next part. And my range is going to be from my midline, negative 1, up 1, and down 1. So my down 1, so negative 1 down 1 is negative 2. So negative 1 minus 1. And then negative 1 plus 1, so up to 0. There you go. Looking pretty good. So this one here just wants to know how have they changed from each other. Do they have the same amplitude? Do they have the same period? Do they have the same horizontal phase shift? Or do they have the same vertical? So which ones differ? So they differ by. So do they have the same amplitude? So look at this graph here. It's going down by 1, up by 1. So these two graphs, yeah, they have the same amplitude. So I'm just looking for what they differ by. They differ by, not by the amplitude. The amplitude is the same. The periods look pretty much the same. It's hard to see what the periods are, but you just hold your fingers here, take the period of 1, kind of shift it over and see, do they look the same? Yeah, they do look the same. So the periods of that graph are the same. Okay. But this one only differs by the horizontal phase shift, the HPS. Definitely not the same place in the same time. And looks like they have the same vertical, the midline, so they have the same vertical shift or vertical displacement there. So this guy here definitely differs by amplitude, or my A value. They definitely differ by a horizontal phase shift, because they're starting at the different spots. The midlines look the same. Yeah, it looks about the same. Do my periods the same? So what I'm going to do is I'm going to put my fingers from the min to the max on the graph. So you can't really see me doing that. But I'm just going to put my fingers down from the min to the max there. And I'm going to shift it over and just see if it kind of matches up with the other graph there. And they kind of do match. So it looks like the periods are the same for both these graphs. So that's what they differ by. Now, if you have one of the older versions of this picture here, I think I tried to make these graphs as accurately as possible to what it was, but they showed you the kind of the junkier ones from like this kind of graphing. So you saw graphs that look like this. Kind of junkier ones, lower resolutions, but they don't do that anymore. Neither will I. I'm not going to give you a low res graph. I'll give you a higher res graph. A little bit easier to see like these ones here. Okay. Now there's two more questions here. For this one here, I just want to know what are all the values and what are all the things down here. So my A value is 2, my B value is 0.3, my C value is 7, and my D value is -5. So that's just reading right off here. Everything here is just written right off that one. They give you a little bit of hints up here. Remember that the horizontal phase shift is C over B. In the middle of the graph, The midline of the graph here is just the vertical shift. So here, let's see if we have what we know. So if you want to, you can pause the video and try this yourself. Come back. Okay, hopefully you tried that. So my amplitude is 2. My period, remember the period is the original period. Now there's no degree symbols up here, so let's just assume that's going to be 2 pi divided by my b. So 2 pi now if I left it as an exact answer, if I just divided 2 divided by 0.3 and I put the pi back in there and go math, enter, enter, I get 20 pi over 3. But if you just go times by pi, you can also get a period of 20, is it to the nearest 10th, 20.9. Cool. Vertical shift to D. So 5 down. I'm going to actually mention that it's moving downwards here. 5 down. Horizontal shift. Remember, this is C over B. 7 divided by 0.3. I want this nearest 10th. So let's say this is 23.3. End up being a positive number. So we put a left in there if you want. Now my range, remember it's going to be from the midline plus the amplitude, or midline minus the amplitude, so wherever the middle of the graph is. So let's do the min first. You always do the min first. So my midline is -5 minus my amplitude of 2. So that's -7. And then I'm going to have my midline, which is -5 plus my amplitude of 2. That's -3. If all else fails, just graph the graph on your calculator and see what it looks like. Put it in Desmos and see what it looks like too. Yeah, pretty good. Yeah, pretty good time right now. The graph of the sinusoidal function is shown. What is the range? What is the equation of its midline? What's the amplitude and what's its period? We could do this for the next 2 graphs, and the next page here is just a little summary of everything we talked about so far. Okay, so my range. Going down to the bottom, looks like it's 0, the bottom of my graph to the top of my graph, 4. I'll put a little YR there. It's a nice continuous graph, so we always put the YR. It is a nice continuous graph like that. My midline, so you just draw a line right down the middle. There's my midline. Y is equal to 2. Amplitude is from the midline up to the bottom, or down to the bottom, sorry. So it looks like it's just going to be 2. And my period was the trickier one to see. So what we can do here, here's 2 pi, right? So that's like 360 degrees. How many of these are in there? 1, 2, 3. So 3 periods in 2 pi. So I could just divide both sides by 3 to get the period by itself. So I have 2 pi over 3. Looking pretty good. Yeah, pretty good. And most of that you can just read right off the graph. All right, you can go down, you can do the math, like they mentioned down here in the little blurb down here, to find the amplitude, max minus min divided by 2, max plus min divided by 2. You can do that as well. But if you just read it right off the graph, just read it right off the graph. Like the min value here, -2, to the max value, +2. So I can just read those right off the graph. Okay. The equation of the midline looks like it's going right down the middle. So y is equal to 0. So right down here is my equation of my midline. Amplitude from here up and from here down. 2, and my period. That's just 1 period in 2 pi. So divide the 1 over, my period is 2 pi. There you go. Just want me to do anything else here? Just describe the graph. We're good there. Awesome. there we go. I've done that one. So the next one we're going to do here, we're actually going to give you some equations, and you are going to analyze them. You're going to maybe graph them in your calculator, or you could just do it, look at the equation itself. And then we're going to talk about some word problems, and we're going to do some more regression. So this time we're going to, rather than regressing polynomial functions, we're going to be regressing sine graphs instead. Get the ABCs from those, and then answer some questions from that. And I'll finish off this chapter. All right, so I'll see you in the next video. Bye.